everyone. I am Shourodip De, third year ECE department. Today, our topic our topic is sampling, aliasing, and reconstruction. First of all, we need to know what is sampling. Sampling is the process of converting a continuous time signal into discrete time signal by measuring its amplitude at regular time intervals. Then, what is Nyquist rate? Nyquist rate is the minimum sampling frequency required to capture all the information in signal, so it can later be perfectly reconstructed. If Fs less than 2 into Fmax, where Fs is the sampling frequency and Fmax is the maximum frequency of the original signal, then it is undersampling and the signal we will see this distortion in the output. Now, if it is Fs equals to 2 into Fmax, then it will be sampling and there will be some distortion, and if it is greater than 2 into fmax, then it is oversampling and there will be no the distortion. Today, our task is to use this equation for sampling to see the sampling effect and Nyquist rate effect and test phase above, equal, and below the 2 into fmax. And this is our today's task. Okay, so this is the program. Now, let's run this program. So let's first give F1 60 Hz, F2 80 Hz, and let's take sampling frequency 140 Hz. Then there we can see this is the output. We took F1 equals to 60 Hz and F2 equals to 80 Hz. So our Nyquist rate is 160 Hz, but we take sampling frequency 140 Hz. So it is below Nyquist rate and it is below sampling, under sampling. So we can see this is the original signal and it is the reconstructed waveform. The signal should be like this, but we will get in the output like this. So this is the distortion or noise. So this is the undersampling case. Now let's take F1 again is 60 Hz. Now let's rerun this again. Let's take F1 again. So now we are taking F1 60 Hz and F2 equals to 80 Hz again. Now let's take sampling frequency 160 Hz. So now our sampling frequency 160 Hz and according to theory Nyquist rate is also 160 Hz. So it is a critical sampling case. Now we can see this is the original signal and this is the original signal we should get in the output, but we will get like this. So it is again we are getting noise. So this is the magnetic spectrum. Reconstruction error is 0.558562. This is the error. Now let's take let run this code again. Now we are taking again the same frequency 60 Hz and 80 Hz. Now let's take sampling frequency 170 Hz. So this is the output we will get. We will get reconstructed signal like this. So we can see we took above Nyquist rate, that is 170 Hz. So Nyquist rate is 160 Hz, but we take sampling frequency 170 Hz. So it is over sampling, but we still getting distortion. So we are still getting distortion, and now reconstruction error is 0.131878, and this is the magnetic spectra. Now let's take sampling frequency 220 Hz. So again we are getting error. We see Nyquist rate 160 Hz and sampling frequency 220 Hz. We are still getting some noise, although it is very low. So from here, it is concluded that although theoretically we should get the original signal above Nyquist rate, we will still getting error. So let's increase the sampling frequency. So now we are increasing the sampling frequency again to 350 Hz. So you can see we will get, so this is the original signal. So there is error is, you can see the error is very low. We will get the original signal. Now let's take the sampling frequency very high. We are taking sampling frequency 1000 Hz. So this is the output we will get. So this is the here it is very low again. This noise, there is no such noise. Magnetic spectra reconstruction error is very low. Thank you.